Right, this video is on naming and writing formulas for covalent compounds, and we're going to use this sheet that you should have. Okay, so quick definition to start with, which is what is a molecular compound or covalent. Okay, so molecular and covalent actually mean the same thing. You might want to write that down. We're going to call them covalent. Some teachers and some college professors call them molecular, so it's good to get used to both terms. But, so a molecular compound or a covalent compound is composed of two nonmetals that share electrons. Okay, so prior to this, we have learned about how to name and write formulas for ionic compounds. So that's where we had the equaling out of charges and dealing with transition metals and Roman numerals and all of that. And so now we have switched over to something totally different, which is how do we name and write formulas for covalent compounds. And it's very different. Okay, so for the kind of the background information is that what's interesting about covalent that doesn't happen with ionic is that sometimes two nonmetals can combine in more than one way. And so there's a pretty famous example, which is the compound of CO2 versus that of CO. Okay, so you're probably pretty familiar with CO2. That's what we exhale. Now CO is something called carbon monoxide, which is extremely poisonous, and it's what is sometimes produced when a furnace malfunctions or it's in car exhaust. It's very poisonous to us and very deadly, and so these two compounds are very different. Okay, notice they only differ by one oxygen. But if we go back to the naming system that we just learned for ionic, which was name the first element, name the second element, and put IDE on the end, this would be carbon oxide, and this would be carbon oxide. Okay, so the problem is it wouldn't be okay for us to call these two compounds by the same name when they're totally different. So because of that, we need a new naming system for covalence. Okay, and that new naming system is where we use prefixes. Okay, if you know what a prefix is, which I'm sure you do from English, a prefix comes in front of a word. So like un is a prefix, re is a prefix. Okay, so you're very familiar with them in the English language. We're going to talk about prefixes that mean numbers. All right, so here we go. Underneath that, you have a little chart. Which are the prefixes for the numbers 1 through 10. Okay, so I'm going to design my chart slightly different, only because I don't want to run out of room. So you're just going to fill in these prefixes in the box. Okay, so there are 10 prefixes that mean the numbers 1 through 10, and most are going to be pretty familiar to you. So the prefix that means 1 is mono, 2 is di, 3 is tri, like a tricycle, 4 is tetra, 5 is penta, okay, like a pentagon. 6 is hexa, like a hexagon, that's an X. Whoop. 7 is hepta, okay, that's one that gives students trouble. 8 is octa, that's a no. 9 is nona, and 10 is deca. Okay, so with covalent naming, we're going to bring these prefixes in when we name covalent compounds. Okay, so there are only 2 rules for naming, and we'll do a couple practice. So if you see underneath, you have practice number 1, H2O, and practice number 2, NO. We'll actually solve those together while we are going through these rules. Okay, so we'll solve those together, or name those together while we do our rules. Okay, so the first rule is that we use a prefix in front of the first element's name only if there is more than one of them. Okay, only if there's more than one. So the first rule says we use a prefix in front of the name of the first element only if there's more than one of them. So if we go down to our practice where we see H2O, the first element is hydrogen, okay? But there's two of them. And so that satisfies this first rule that I'm going to need a prefix because there's more than one. And the prefix for two is di, so we put that in front of the word. And we call this dihydrogen. Now I haven't finished the name, okay, but that's how I start. Now in my second practice, the first element is nitrogen. But notice there's only one of them. So this is the exception, okay? So use a prefix only if there's more than one. There's only one, so I'm not going to use a prefix, and I'm just going to leave it as nitrogen. The second rule is that you always use a prefix for the second element, regardless of how many there are. And you change the ending to "ide," just like in ionics. Okay, so the second rule says you always use a prefix for the second element, and we're going to change the ending to "ide." So this is oxygen. It's going to be oxide, but I'm going to use a prefix regardless of how many there are. There's only one. That prefix is mono, and so this is monoxide, but we call it monoxide. Okay, so this is actually dihydrogen monoxide is the true name for water. Actually, same thing here. One oxygen, oxide, so monoxide or monoxide. And so this is nitrogen monoxide. Okay, so basically the rules for naming are you use a prefix all the time unless there's only one of the first element. And you change the ending to "ide" of the second one. That's it. So there's 6 more practice. If you would take a minute and solve those. Again, I would recommend you pause the video and then you can check my answers. Okay, so here we go. Second one, the third one, I guess. This would be nitrogen dioxide. Okay, notice there's no prefix in front because there's only one. Nitrogen dioxide. This is going to be sulfur hexafluoride. Okay, sulfur hexafluoride. This one is carbon tetrachloride. Prefix for 4 is tetra. PBr5 is phosphorus pentabromide. Number 7, there are 4 of the first element, so I need a prefix. So this is tetraphosphorus trisulfide. That one sounds made up, doesn't it? Tetraphosphorus trisulfide. And then my last one that I have totally run out of room to write, but I'll try to squeeze it in, is chlorine trifluoride. Okay, chlorine trifluoride. So there you go. That's naming covalent. Pretty easy. Okay, if you flip your paper over to the back, we're going to do how to write a formula. So formula writing is even simpler. And I'll do one example with you. so the first rule is use prefixes to decide on number of atoms. And then the second rule is use subscripts to indicate the number of atoms. Okay, this is almost so simple that you don't need rules for it. So use the prefixes to decide how many atoms we have, and then use subscripts to indicate how many atoms there are. And it's as simple as this. This is the first practice one. Tetraphosphorus hex oxide. So tetra means 4, which means I must have 4 phosphoruses. So P4. And then hex or hexa means 6. So that must be 6 oxygens. And so this formula is P4O6, and I'm done. There's no charge balancing. There are no transition metals. Nothing. Covalent formula writing is so very simple. So if you run down those 5 examples, I'll put answers up real fast, and that's it. That is it. You probably don't even need these answers, but I'm going to do it anyway. Okay, so here we go. Iodine tribromide would be I, Br3. Boron trichloride would be BCl3. Silicon tetrachloride would be SiCl4. Nitrogen monoxide would be NO. And dinitrogen tetrahydride would be N2. Hydride is hydrogen. That's the only tricky part on here. And so that would be N2H4. And that is formula writing for covalent. And that is where this video will end.